Now we are in quadratic equations. I wanted to look at again the standard form of a quadratic equation and read the definition of what is a quadratic equation. Now there are three ways in solving quadratic equation. First one, it's by factoring. Second, by completing squares. And the third one is by quadratic formula. Again, there are three ways in order for you to find the value for x here. And note that the highest power or the degree of the equation here is a power of 2. Quadratic means a power of 2. So it means that there are two values for your x here, or you're looking for two values for x. Try to recall in the previous chapter, you have linear equation. When you say linear, that's a power of 1. Here, this is a power of 2. So that one has only one value for x because that's a power of 1. Here, this is a power of 2. In the future um, topics or chapters, you'll be dealing with a power of 3. When you have a power of 3, it means that you're looking for 3 values for x, and it continues going to the higher power. So that number there refers to how many x values you're looking for. So when you do factoring, so I'll just show you the property you use for factoring. So you need to know the zero factor property. So that's the one you use in order for you to find the x value. And then here's another property. We call that square root property. So we need that also in order for us to find the x value. So note that you have a positive value here and the other one is a negative. So total of two values for x. That's for factoring. Now for the second way to solve, here's the rules. So I want to give you time to read and understand the different steps here. Then I'll show you in a few minutes on how are we going to apply this using an example. The third one, it's quadratic formula. So having the standard equation for quadratic, you can see over here, this is the one. You just apply those values. So your A is the number beside your x squared, and B is the number beside your x, and then your C is the constant term, Then you just apply that using this formula here and calculate. Then that would be your answer. So you'll be looking for two answers also. Okay, so this is just a reminder for the quadratic formula. So just be careful with the sign. So here's the quadratic again formula. So memorize this one. You need this in solving for quadratic equation. Now, if you cannot do factoring or you cannot do completing of squares, all problems in quadratic equation can be solved using this formula. Okay, so let's have an example. Sample 1, that's by factoring. So this is the first way, by factoring. Let's say the given problem is x squared minus 6x plus 8 equals 0. So when you're working with quadratic equations, make it sure that the right side of the equation is 0. If not 0, you have to move that term to the left side to combine that with a constant term. So the right side will become a 0. So always the left contains those variables and the right side is 0, or the other way around. So what I'm trying to say, one of the side should be a 0 and the rest would be on the other side. Okay, so this is by factoring. So by trial and error, you will do two binomials here equals 0. So the first one that we have to consider, it's the first term. So this is our first term, x squared, and the factors for x squared, it's obviously x times x. There's only one set of factors there. So that would be x here and x here. And the next, we need to consider 8. So 8 has 8 times 1. So that's the first factor. The second factor would be 4 times 2. And then since the middle term, it's a negative, so you have a negative here, then that would be negative that you have to consider also, the negative factors of 8. So you say negative 8 times negative 1, that's positive 8, similar to the next one. So now you have to choose which of these factors that fits to your problem. And your goal is to look at the middle term, which is a negative 6. So I'm going to pick the last one. The last one, because when I add negative 4 plus negative 2, it gives you a negative 6. So that would be the right match. You can always check by multiplying these two factors, and it should be going back to the original problem. So you will get the same answer or match the given problem. After that, you apply the zero factor property, the one that you've seen a while ago. First factor, set that to 0, and then the second factor, x minus 2, set that to 0 also. And then you just find the value for x. So since we have a negative 4 on the left, we move that to right, becomes a positive 4. And then if you're using elimination, you can do plus 4 on the left and plus 4 to the right. It gives you the same result. And do the same thing on the right side. Moving negative 2 from left to right, then you will get a positive 2. It changes the sign as you move the number. So in a solution set, you will have 2 and 4. To make it sure also, you need to check your answer by plugging in. So last time we know how to check by plugging in to the original equation. So just plug in 2 to x and then calculate. So it should be a true statement. So 2 is a valid answer. 4 do the same thing and it should be true statement. So in case you're going to get a false statement, um, you're going to ignore or disregard that answer and do not put that in your solution set as part of your final answer. Okay, so that's by factoring. Next, by completing squares. Now, a while ago, I've shown you the rules of completing squares. Okay, so I will show that again towards the end of this presentation. So you will make a review on what we did here. But I will go over in a shorter way on how to complete squares. So we'll be using the same example, x squared minus 6x plus 8 is equal to 0. Now the first step here is to move the constant term. The constant term is 8. Move this going to the right. So we're moving that one to the right and have a space there. So do not replace that, it's just a space. So I put a little bit space after negative 6x, and then 8 is now a negative 8 on the right side. And then I have to apply the rule. It says that the rule said that a should be a 1, or a is 1. So a is over here, that's a 1. If it's not a 1, you have to divide that number, whatever the number is, with that number to all the terms in the equation. So it becomes 1. So right now it's a 1. So we have to proceed to the next rule, which is b divided by 2, or b times 1/2, and you square that one. So what would be our b now? Our b is negative 6 divided by 2. You square that, that would be negative 3 square, right? And that negative 3 actually goes to your binomial on the next line. So that would be equal to 9. So 9 goes here, and since you're adding 9 to the left side to balance the equation, you have to do the same thing on the right side. Because if you're not doing that, you're changing the whole equation. So if you're going to look at that now, it balances the equation. So you added 9 to the left, you add also 9. The whole purpose of doing this is just for you to manipulate the equation and do a little bit different from the first way of finding your x. So, and we call this completing squares. So as we move on to the second line, it's a binomial, and you have x here. Whatever your answer here, I'll underline that. That's a minus 3 goes here, and it's a power of 2. And then negative 8 plus 9, that would be a 1. Now note that when you're factoring the whole trinomial on the left side, this whole trinomial, the factor would be x minus 3 power of 2. So it's like x minus 3 times x minus 3. You can always check that by trial and error. So that's how you know. After doing that, you apply the square root factor property, the one that I've shown you earlier. So we take square root on both sides to remove the power of 2 here, and we do the same thing on the other side. So when you're taking the square root with a square, that cancels out. So this square root symbol and the power of 2 cancels out. So it means what's left would be x minus 3. And then taking the square root of 1, you have two possible answers. If you remember the square root property, that should be plus and minus, right? Plus and minus 1. So therefore, there are two answers here. The first one is x minus 3 is equal to positive 1. The other one is x minus 3 equals negative 1. And then calculating your x, you have x here equals, moving negative 3 to the right side, it becomes positive 3. So x therefore is 1 plus 3 is 4. So that's our first value for x. Do the same thing on the right side. Move negative 3 to the right side, it becomes a positive 3. So that's a minus 1 plus 3. So it gives you positive 2. So in a solution set, you can always check this by plugging in back to the original equation. So 2 and 4 are valid answers. So again, you can always check. Don't forget to check. Okay, checking is the key for you to confirm if really you have two answers. Because sometimes there will be in the next succeeding chapters that you will know that you will have only one out of two, or maybe nothing at all if you have undefined answers. Okay, and you're going back to empty sets. Okay, so this is by completing the square or completing squares. Okay, so let's move on to the last one, which is by quadratic formula. We'll use the same example. And then applying quadratic formula, you've seen that your A is here, B is here, and this is your C. Okay, so the formula, it's, you memorize it, you need to. So x equals negative b radical or square root of b squared minus 4ac divided by 2a. Now, you have to take note also that b squared minus 4ac is your discriminant. So this is what we call discriminant. I'll show you after these three ways to solve for your quadratic equation. So discriminant is just knowing what is your b, what is your a, what is your c, and apply b squared minus 4ac, and then you will see the table how many solutions that is irrational, rational, or none. So just refer back to the table. So here we're just plugging in. Our b is a negative 6. So we already have a negative here, so be careful. That's a negative 6 here. And then square root of negative 6 power of 2, that's your rb squared minus 4. Our a is 1 and our c is 8. And then divided by 2, our a is 1. If you don't have anything beside your x squared, that's understood as 1. And then let's continue. Okay, our answer now is equal to 6. That's a negative times a negative, it's 6. And then the inside, you have negative 6 times a negative 6. So that should be 36. And then you subtract that to 4 times 8 is 32, right? And you'll get a 4. So take the square root of 4, it gives you 2. So I'll just mark the formula here plus and minus. So we lift that out, plus and minus. So that should be plus and minus because you have two values for your x here. So the formula has that one. And then that would be a 2, right? Okay. I'll just show you. That's a 4. So it's a 36 minus 32. So that would be a 4, right? Divided by 2. I'll just do step by step. And then you have 6 here. Then that's a plus and minus 2 now, divided by 2. So you have two answers. So the first x value, that should be 6 plus 2, that should be 8 divided by 2 is a 4. And the other value would be the minus sign. So that should be 6 minus 2, that should be a 4, divided by 2 is a 2. So you're getting the same answers as we've shown you the first way, that's by factoring, the second by completing of squares, and now by quadratic formula. So we're going back to the solution set. Solution set, you have 2 comma 4. And that would be our final answer. Okay, again, you can always check by plugging in the numbers 2 and 4. Okay. So that's by quadratic formula. Okay, one more time. I'm going back to the slide here and the rules for completing the square. So I just want you to look at again if we followed the rules there. Okay, and then we have the quadratic formula. So this is the one that we need, the plus and minus, in order for us to have two answers. So that's the one that we inserted plus and minus there. And the discriminant is right here. So you can see that on the next slide for the discriminant. So we need to know that because this is part of quadratic equations. We need to know where's our discriminant. So here's the table. Okay, so that's the definition for the discriminant there. And then the table that you have to follow in order for you to actually calculate or answer. So first you calculate using your b squared minus 4ac, and then you make a statement. So when you're looking at this first column, you can see that whatever you answers, it could be a positive and perfect square, or it could be positive but not perfect square, or it could be a zero, could be a negative. Then your answer would be on the second column and the third column. So that would be your answer. So if you're going to um, look at our example, you're just plugging in and then make a statement. So that's what you need to do here. Okay, so as you can see, we're just plugging in the value using the formula. So this is our A here, our B, our C. After doing that, we got 84. It's a positive. It's a positive. That's from the table and not a perfect square, right? So 84, it's not. 81 is, but 84, it's not. So it's not perfect. So we make a conclusion, and then the conclusion is on the third column of the table. It says two distinct irrational solutions. So if you're going to go back on that one and see if that is right, it's positive, not perfect. So positive, not perfect, it's over here. So that's the one. Second row. So your answer would be, the number of solutions would be two solutions, irrational, that's the type. Or you can say two irrational solutions. So that's it for quadratic equation. Just remembering that quadratic formula.